Welcome back. We've mastered the race. We've built the engine, optimized the track surface, and even added a second dimension with GCX-GC. But today, we face the ultimate boss of analytical chemistry. We are moving beyond weight and time. We are entering the spatial realm. Welcome to the third dimension of mass spectrometry, ion mobility. Imagine you are tracking two suspects. They weigh exactly the same, M/Z 400.1234. They have the same name. They even arrived at the airport, your detector, at exactly the same time. On paper, in the flatland of 1D and 2D chromatography, they are identical. But in person, one is a world-class athlete, and the other is a folded umbrella. How do you tell them apart? In the lab, we call these isomers. To solve this case, mass and time are no longer enough. We need shape. Today, we navigate the final frontier of identification. Sector A, the failure of the flat world. Why M/Z and RT eventually let you down. Sector B, the chemical wind tunnel, the physics of ion mobility. Sector C, the molecular fingerprint, defining the collisional cross section or CCS. And Sector D, strategic intelligence, how we solve the nightmares of lipids and sugars. We've been taught that high-res MS is the gold standard. And it is. But MEM/Z only tells you the composition. Retention time tells you the polarity. But biology is 3D. When your data tells you it's a specific metabolite, but the biological results say otherwise, you're missing a dimension. Actually, have you ever felt that MEM/Z 400.1234 just isn't telling you the whole story? That's because nature loves isobars and isomers, different structures with the exact same weight. How do we add shape? We use ion mobility spectrometry, or IMS. Think of it as a chemical wind tunnel. After ionization, we force the ions through a chamber filled with a buffer gas, usually nitrogen or helium. We apply an electric field to pull them through, but the gas molecules act as a constant headwind. This is where the physics of the stride comes in. Look at this analogy. Compare a stretched-out rope to a tangled ball of the same weight. Which one fights the wind better? The tangled ball is compact. It zips through the gas. The stretched rope has more surface area. It collides with more gas molecules and slows down. This resistance is what we measure. This is the birth of the collisional cross section, CCS. It isn't just a number. It is the physical shadow or the footprint your molecule casts in the gas phase. Here is why a specialist loves CCS. Retention time is like a mood ring. It changes based on the column's age, the mobile phase brand, or the humidity in the lab. But CCS is an intrinsic property. As long as you control the temperature and the gas type, a molecule's CCS is the same in New York as it is in Taipei. It is a fundamental structural descriptor. By adding CCS to your search criteria, you move from tentative identification to structural certainty. Let's talk about the lipid/sugar nightmare. Lipids are the bane of traditional MS because they have endless cis and trans variations. In the clinic, the difference between a good lipid and a bad lipid is often just the position of one double bond. IMS resolves this in milliseconds. Actually, in clinical proteomics and metabolomics, IMS is the difference between a guess and a diagnosis. It allows us to see the folding of proteins and the orientation of sugars that determine if a drug will work or fail. By adding IMS, you are cleaning your spectra in the gas phase after they leave the column but before they hit the detector. You are removing chemical noise that even the best chromatography couldn't touch. You are no longer just weighing the molecule, you are measuring its stride. You are seeing the 3D reality of the chemical world. Summary: respect the shape. Shape is the final arbiter of truth. You've learned the logic of shape. Now it's time to master the math. Join me in our next unit, Module 4 to 6, the gold standard, where we learn the exact calculations for drift tube IMS to identify unknowns with fundamental, primary precision. We are going to turn that shadow into a hard number. I'll see you in the next mission.